It feels like every day there's a new way AI is weaving itself into our real-time interactions. From those subtle suggestions in documents to, well, increasingly natural voices on customer service lines. It's clearly a big shift.
It really is. Not just a trend.
And it makes you wonder, what's the engine, under the hood? How are developers actually building these applications that can talk to us so seamlessly in real time?
That's exactly what we're exploring today. We're doing a deep dive into LiveKit. It's an open source platform built specifically for real-time communication.
Okay.
So think voice, video, yes, but also the underlying infrastructure needed for these advanced multimodal AI applications we're starting to see everywhere.
Right, so it's not just patching things together. LiveKit offers this unified toolkit.
Exactly.
And our mission today, looking at the docs we've got, is to really unpack their LiveKit agents framework. And we're especially interested in how it handles something we all know, the good old telephone call.
Precisely. We want to figure out how LiveKit lets developers build AI agents that aren't just stuck behind a screen,
Yeah.
but can actually join phone calls, bring some real intelligence to those everyday chats. Imagine an AI answering, guiding you through options.
Hey.
That's the kind of thing we're talking about.
It's pretty impressive how broad LiveKit is for developers. They've got SDKs, software development kits for just a huge list of languages.
Right.
Python, Node.js, JavaScript, Swift, Android, Flutter, React Native, even Unity for game dev, plus Go, Rust, Ruby, Kotlin Java, PHP.
Wow, yeah.
That seems to cover basically all the big platforms, right? iOS, macOS, visionOS, tvOS, the web.
And for developers looking to speed up the UI side, they also have pre-built UI components for React, Swift across Apple stuff and Android. And then if you're building the backend services, there are server APIs too. Go, Node.js, Ruby, Kotlin, Java, Python, PHP. It's really a complete ecosystem, very versatile.
Okay, so let's unpack this agents framework itself. When a developer thinks about building real-time AI, what's the key thing LiveKit agents offers? What makes it stand out?
Well, at its core, LiveKit agents built using Python or Node.js lets you build what they call production-grade AI agents.
Production grade, so serious stuff.
Yeah, not just toys. They're designed to be robust, scalable, ready for real-world use, handling multimodal and voice AI in real time. And the really interesting part is how it simplifies getting AI into those live interactions.
So these agents can basically just walk into a LiveKit room, the place where the communication happens, like a person with a webcam.
Exactly like that. The framework makes it surprisingly easy to take, real-time media, audio, video, text, whatever, and just feed it into your AI pipeline.
Doesn't matter which AI provider you use.
Nope, any provider. And then the agent can publish its results, its responses, right back into that same room, instantly. Makes it truly interactive.
That sounds incredibly efficient. I saw they mentioned a quick start guide for getting your hands dirty.
They did. A voice AI quick start. Promises you can build a basic voice assistant in Python in under 10 minutes.
Wow, okay.
It's a great way to just feel how it works. And if you want to dig deeper, the full Python source code, loads of examples, it's all on GitHub.
So beyond that basic assistant, what are some real-world scenarios? Where could these agents really, shine?
Oh, the possibilities are really diverse. Think about multimodal assistants, not just voice, but showing things on screen, maybe even reacting to visuals. Telehealth is a big one. An AI could do initial patient intake, ask basic questions, freeing up doctors and nurses.
Right. Efficiency.
Call centers, definitely. Inbound calls, outbound calls. Huge potential there. Real-time translation happening right inside the conversation.
Breaking down language barriers.
Exactly. Or, powering smarter NPCs in games, or giving robots a more intuitive way to interact, putting their brain in the cloud, basically.
They had some specific examples too, didn't they? Recipes?
Yeah, those really make it concrete.
Yeah. Like
a medical office triage agent assessing symptoms, directing patients. A restaurant agent taking your order naturally.
Like talking to a person.
Hopefully.
Yeah.
A company directory agent using voice, or even those touch-tone keypad presses DTMF to route calls. And a pipeline translator showing off that real-time translation. These recipes really show you what's possible.
Okay, so the agent is this smart go-between for the user and the AI models. But, well, we all know internet connections aren't always perfect. How does LiveKit agents handle flaky networks?
That's a really critical point. And yeah, the framework is built for that. It acts as a stateful real-time bridge.
Stateful.
Meaning it keeps track of the conversation context. So the heavy AI processing happens in data centers, right? Stable connections there. but the user might be on patchy mobile or home Wi-Fi.
Yeah, happens all the time.
So LiveKit uses WebRTC for that connection between the users and a browser, app, even a phone call via telephony and the agent.
WebRTC, that's the tech for real-time stuff online, right? Like video chat.
Exactly. It's designed to handle network hiccups, packet loss, jitter, keeps the conversation flowing smoother, kind of like video streaming buffers. So you get that resilience where you need it most on the user side. The agent then talks to the back-end AI services using standard things like HTTP and WebSockets. You don't need to become a WebRTC expert yourself.
And it sounded like the framework has built-in help for the tricky parts of real-time voice AI.
It does. They've included components specifically for managing the flow of streaming audio through speech-to-text, STT, then to the large language model, LLM, and finally text-to-speech, TTS, back to the user.
A whole pipeline.
Right. And it handled turn detection, knowing when someone's finished talking. That's crucial for natural conversation. Plus, interruption handling, so it's not so rigid. And tools for orchestrating the LLM side.
And plugins for AI providers.
Yep, plugins for major AI providers to make integration simpler.
It's not just voice, though, is it? It handles other things, too.
That's right. It's built for voice, video, and text processing. So you can build truly multimodal agents. It also supports tool use.
Ah, where the LLM can call out to other systems.
Exactly. Call external functions, APIs, get data, perform actions. They even mention forwarding those tool calls to your front-end app if needed, which is pretty neat for tight UI integration. And for really complex tasks, it supports multi-agent handoffs, so you could have different specialized agents collaborating.
Interesting. Beyond those core bits, what else makes the agents framework attractive for developers?
Quite a few things. They highlight easy integration with lots of AI providers. Their turn detection is apparently state-of-the-art, aiming for that human-like flow.
Okay.
It's a very code-centric, giving developers flexibility. And importantly, it's built for production. Think work orchestration, load balancing, Kubernetes support for scaling.
And it's open source?
Yep, Apache 2.0 license, full transparency, community support.
Okay, makes sense. Now, how do these agents actually connect? How do they start running inside LiveKit?
So when you run your agent code, it registers itself as a worker with the LiveKit server.
A worker.
This worker then listens for a dispatch request. When a request comes in, like needing an agent in a new room, the worker starts up a job subprocess. And it's that job that actually joins the LiveKit room.
Okay.
By default, whenever a new room is created in your LiveKit project, a worker gets dispatched to it, ready to go.
So once the agent, the job, and a user are in the same room, how do they talk to each other?
They communicate using LiveKit's underlying WebRTC system. That gives you the reliable, low-latency connection we talked about, even with network issues.
Right.
And key for today's focus, LiveKit also fully supports telephony. So a user can join that same room, that same conversation, just by making a regular phone call.
And if someone wants the bigger picture, beyond just the agents framework?
Yeah, there's an Intro to LiveKit guide for the whole platform overview. And for agents specifically, they've got a ton of guides. The Voice AI Quick Start, detailed recipes, that intro guide, guides on building web and mobile front ends, specifics on telephony integration.
Lots of reading material.
Definitely. Building voice agents, the worker lifecycle, deploying to production, integrating specific AI providers. It's very well documented.
All right, let's zoom right in on that telephony part. How does LiveKit actually connect to the, the traditional phone network?
That's where LiveKit's IP comes in. SAP Session Initiation Protocol is basically the standard language used for setting up, managing, and ending real-time sessions online, including voice and video. Think of it as the control system for internet calls.
Okay.
LiveKit's IP acts as the bridge. It connects your LiveKit setup to traditional phone networks via a SIP provider.
So you can get phone calls into LiveKit and make calls out.
Exactly. Receive calls, make calls, and crucially for us, have your AI voice agents handle or participate in those calls. Your AI answer the customer service line. That's the idea.
So my AI agent isn't just in an app. It could actually answer my phone number. That's pretty significant. What are the main pieces that make this SIP thing work?
There are a few core concepts. First, the SIP participant. Everyone involved, the caller, the person called, the AI agent is treated as a LiveKit participant.
Just like a user in a video call.
Pretty much. They're managed via the normal participant APIs, but they have extra SIP-specific details. For incoming calls, LiveKit automatically creates one. For outgoing calls from your AI, you create one using the API.
Okay, participants. And then trunks. That sounds like the connection itself.
You got it. Trunks are the virtual paths between your SIP provider, the company giving you the phone number and connection, and your LiveKit system.
So I need a provider, like Twilio or someone.
Right. You configure a trunk with that provider in LiveKit. An inbound trunk accepts calls coming in, maybe restricted by IP or number. An outbound trunk is for making calls out.
Do I need separate ones?
Conveniently, no. LiveKit lets you use the same provider trunk for both inbound and outbound. You just set it up once.
And how do you tell LiveKit where to send an incoming call? Like, which room should it go to, where my agent might be waiting?
That's handled by dispatch rules. You link these rules to a trunk. They tell LiveKit how to route incoming calls.
Simple routing, or can it be clever?
It can be pretty flexible. Route all calls on a trunk to one room, or use different rules to send calls to different rooms based on, say, the number called. You can even have multiple rules on one trunk using different pins or extensions dialed by the caller.
Okay.
And these rules can also add custom attributes to the SIP participant, useful for passing info along, maybe based on the caller ID or something.
So architecturally, you've got the SI provider, the main LiveKit server doing orchestration, and this LiveKit SUP piece handling the phone details. How do they fit together?
In LiveKit Cloud, yeah, it's like that. Provider LiveKit server, handling APIs, managing trunks rules, creating participants rooms.
Right.
LiveKit SIP component, handling the actual SIP messages, authentication, matching calls to rules.
And if I self-host?
If you self-host, you need to deploy this SIP service as a separate component alongside the main LiveKit server.
Got it. And for developers building this, are there specific SDKs for this IP side?
Yes, there's a LiveKit CP SDK. They often just call it the CP PayTie. It's available in multiple languages and gives you the specific functions needed to control this IP features programmatically.
Is it tricky to set up with providers? Have they tested specific ones?
Well, they say it's designed to work with any standard SIP provider, but they specifically mention testing thoroughly with Twilio, Telnix, Exotel, and Plivo.
Okay, so those are probably good starting points.
Probably a smoother setup, yeah.
What about actual phone features? Can it handle, like, keypad tones, press 1 for sales, that kind of thing?
Absolutely. DTMF, those touch tones are supported. You configure it when making an outbound call via the Creates Participant API, essential for IVRs.
And transferring calls.
Yep, SUP refer is supported. You use the Transfer Participant API, lets your agent or anyone transfer the call to another phone number, or even a SUP URI, like an internet phone address.
Any other advanced bits?
You can map custom X headers from this IP call setup into participant attributes in LiveKit. That's pretty powerful for passing specific context or routing info.
And noise cancellation, that seems super important for AI on a phone call. Clear audio is key.
Totally. The integrated Crist AI noise cancellation, you can turn it on for inbound and outbound audio streams.
Makes a big difference, I bet.
Huge difference, especially in noisy places. For the AI, it means better turn detection, more accurate transcriptions from the STT, cleaner recordings, just better overall performance.
How do you enable it?
It's an attribute you set on the inbound trunk config for incoming calls and in the Creates a Participant request for outgoing calls.
So if I'm listening and I want to start building this AI phone stuff with LiveKit, what are the next steps in the docs?
They lay it out pretty clearly. First, set up your SIP trunk, get a number, configure your provider to talk to LiveKit SIP.
Right.
Then there are guides specifically for accepting inbound calls and for making outbound calls.
And for the AI part?
There's a dedicated voice AI telephony guide that walks you through integrating the agents with the phone calls.
Okay, we've gone deep on agents and telephony, but LiveKit is bigger than that, as you said. Can we just quickly recap the main parts of the whole ecosystem?
Sure. So the absolute core is building real-time voice, video, and multimodal AI apps. The building blocks are rooms, the virtual spaces, participants, users, or AIs in a room, and tracks the actual audio, video, or data streams they share.
And around that core, security, management.
Yeah, all the essentials.
Yeah.
Authentication, a command line tool, CLI, for managing things, guides for setting up apps, connecting, handling real-time events.
Tokens, webhooks.
Tokens for secure auth, APIs for managing rooms and participants programmatically, and webhooks so your backend can react to things happening in LiveKit.
Recording, that often comes up.
Yep, strong recording features, composite recordings, mixing video tracks together, individual track recording, different output options, streaming destination.
Auto recording.
Auto egress, yeah, for automatic handling, custom templates for the output look, a full egress API for code control, encoder settings too.
And actually running LiveKit, deployment, scaling.
They cover it all. Running locally, on VMs, Kubernetes for scaling, even multi-region setups for global apps. Firewall configuration guidance, naturally. An analytics API for performance insights, plus features like that enhance crisp noise cancellation. Benchmarks, deployment guides for egress, ingress, the SSIP server if you self-host. It's comprehensive.
And ways to get started fast.
Definitely. The SDK quick starts are key for that. Just get something basic running quickly.
Right.
And of course, there's LiveKit Cloud if you don't want to manage the infrastructure yourself.
Right, the managed option. And finally, those recipes you mentioned seems like a goldmine of examples.
It really is a huge list. The voice AI quick start, the medical triage, restaurant agent we talked about.
Yeah.
But also things like live paint, collaborative drawing with AI feedback, push-to-talk agents, background audio tricks.
Translation examples.
Several translation recipes. Keyword detection, using Twilio Voice alongside LiveKit, IVR agents, the company directory, phone caller examples, SIP handoffs, SIP lifecycle demos, answering calls, survey callers, advanced AI stuff like Chain of Thought, RAG with Lamy Index or their own docs, a movie phone-like bot, context management, interrupting users, content filtering, vision assistance, Raspberry Pi transcribers, metrics tracking examples for LLM, FTT, TTS, VAD. It just goes on and on. It's incredibly rich.
Okay. So bringing it all together then, LiveKit agents, especially with that SIP integration, it really opens up some powerful ways to build AI apps that talk to users, really flexibly, even over a regular phone line.
Absolutely. It's about bringing intelligence into all types of conversations. You've got the open source framework, great docs, loads of SDKs, powerful features like SIP. It makes LiveKit a really strong contender for anyone serious about building the next generation of real-time AI communication.
And it feels like it's all there for you, the docs, the SDKs, those recipes. It really invites you to just jump in and start creating that future. So here's a final thought for you, the listener. With platforms like LiveKit making this kind of advanced real-time AI so much more accessible, so much more capable, how is this going to fundamentally change how we interact, not just with tech, but maybe even how we connect with each other in the future? Definitely worth checking out the LiveKit docs and thinking about the possibilities.